For the first example here, if you look at where the vertex is, remember we need to switch the sign here. So it's x take away, and then it's actually positive 3, so that matches with positive 3 as our x-coordinate of our vertex. The y-coordinate is exactly what we see here, the plus 4. We know from the fact that this piece is a positive 2 that our parabola is opening up. Now, as far as our equation for our axis of symmetry, that really matches the x-coordinate of the vertex. It's x equals 3. And your optimal value comes from the fact that it's opening up, so it goes this direction. We know it reaches a minimum value, and the minimum value it reaches matches with the 4. That is the y-coordinate of our vertex. So the min comes from the fact that it's opening up. Now, as far as the numbers of zeros go, or the x-intercepts go, what I'm really looking at is what this graph is going to look like in terms of a sketch. Now, I'm just going to do a little sketch up above the equation itself here because I don't have a lot of room to work with. We know that, there's my x-axis and my y-axis. The vertex is at positive 3, positive 4. So right somewhere up in here. And it's opening up. I'm not putting a scale on it. I'm just getting a ballpark of where that is. If I look at that diagram, I'm seeing that that graph will never cross the x-axis. So in terms of number of zeros, number of x-intercepts, I put none for that one. So if you're having trouble filling in the number of zeros or x-intercepts, consider where the vertex is and the direction of opening, do a little sketch, and then it'll help you decide how many x-intercepts you will have. So if you didn't get that, put me on pause before the rest of the solutions go in. Check your work here and just make sure that I haven't made any mistakes. Make sure that we agree with everything. If we don't, we need to find out if I've made a mistake or if you've made a mistake and clean up any misunderstandings. All right, if you haven't tried example 2, try that one. See what you can figure out from the information in the questions, and then check it on the next part of this video when I switch to the next page. Okay, if we look at this question, we've got a ball is hit into the air. Its height is represented by the letter h, and it's in meters, after t seconds. So t is time in seconds, and it can be approximated by the equation that's given here. So this is vertex form. I already know that the parabola is opening down. I know my vertex coordinates will be positive 4 and 120. So based on the equation, those are the coordinates of the vertex. Now, if you think about the vertex, we know we have 4 and 120, so way up at high. I don't have a scale on this. I don't know exactly where things are going to land in terms of the axes, and in fact, I think I've done a poor job on that. So let me try that again. So let's say the parabola moves that way. This is your h-axis and your t-axis right here. In what direction does the parabola open? We already said this is going to open down because of that negative 5, the negative a value. What does the vertex represent in the context of the question? So the context means you've got to go back to the story and talk about the height and the time and the fact that it's a ball that's hit into the air. So in terms of this, the ball is hit into the air, it reaches this vertex. Now the vertex is representing the time, so it will be a t value of 4, and the h value, so this is t is 4, and the h is the 120. And I know that because the t is in place of x, and x comes before y, and the h is like the y, it comes second in my ordered pair. So what does this mean in terms of context of the question? Well, it means at time 4 seconds, the height of the ball is 120 meters, and it's its maximum height there. So it means the vertex represents that the ball reaches its maximum, because it's opening down, height of 120 meters at a time of 4 seconds since being hit, because the ball was hit into the air. So that's really what we're meaning by our what the context is, what the vertex actually represents. So if you were actually given the graph, it would have been one of those questions at the beginning when you used Desmos and we put it into the equation and then we asked you when does the ball reach the maximum height? What is the maximum height? So it's working the reverse of this now. Now, what was the height of the ball 1 second after being hit? So we are being asked, so just to help you decipher what to do, what was the height? So what was required, or what's being asked for you to find, is the height. So height is unknown, but we're telling you something here. We've got the t being equal to 1 second. So that means I can use that equation that was given, and where I have t, we want to replace that t with the value of 1. So we put that in for the 1, and then it's just a matter of using our calculator or using our mental calculator here, since I have to write it out anyway. BEDMAS says do inside the brackets first, so 1 take away 4 is -3. Then exponents. Exponent is -3 times -3, which is a 9. And then multiply before adding, so -5 times 9 is -45. And then we're adding 120 to it, so positive 120, and then subtract 45. Subtract 20 would take us down to 100. Subtract another 20 would take us down to 80. Subtract another 5 would take us down to 75. So this would equal 75. So the ball was 75 meters high 1 second after it was hit. So the ball was 75 meters high 1 second after it was hit. Now the next part is asking from what height, so I'm going to switch to green here just so that I don't get mixed up with the blue part, the part for question D. From what height, so the question is to find the height, was the ball hit? Now this, in question D, the time was explicit here. It explicitly gave you that the t was equal to 1 second. This one's an implicit and implied value for time. So at the moment the ball was hit, that's when time begins. Time is starting at 0. So when you see something where it says when the ball was hit, or the initial height of the ball, if it's asking for the initial height of the ball, it also is implying, or implicit information is that time is equal to 0. So now what we're going to do is take our equation, and where we have that t, we're going to replace that with 0. And I'm going to expedite my calculations here because I don't have a lot of room to work with. -4 squared would be a 16, and then I have 16 times 5, which I am going to grab my calculator with to do the calculation, only because I'm tired and my brain sometimes makes mistakes. So that's -80. So I've got a -80, and to that I'm going to add 120, and I have 40. So the initial ball was hit, or the ball was initially hit from a height of 40 meters. So maybe it was hit on top of the roof of a building, like somebody's up at the top of the roof of a building and hitting the ball off of there and just seeing how far they can rock that thing out of the ballpark. All right, so from here I would make my therefore statement, and we would add that in. Okay, our last part here, part F. At what times was the ball's height 100 meters? So in terms of solving this one, I can see that I've been given the height values. So height is equal to 100. That's explicitly stated in the question. And I'm asked for at what times. So time is equal to a question mark. So this is a little bit trickier here in terms of how to solve it. So I'm going to start with my equation and put 100 in for where the h is. That's going to equal -5 t take away 4 all squared plus 120. Now our job here is to solve for t, get the value of t. Now to do this, I see t only appearing once in the entire equation. It's right here where I've underlined it. So what I can do is solve like I would solve any other equation, linear equation, by undoing the things that are around it in the reverse order of BEDMAS. So I'm going to get rid of any adding or subtracting first. So when I look at this, I see a plus 120 on the end. I'm going to undo that by subtracting 120 from both sides of the equation. So I have 100 take away 120. That's going to result in -20 being equal to -5 bracket t take away 4 all squared. And this other piece, the plus 120 and the minus 120, now that's gone. The next thing I need to undo in terms of BEDMAS backwards is this multiplication of -5. This is multiplying my bracket. So what I want to do is undo that by dividing the -5 out. But I have to divide both sides by -5 to keep it balanced. So the -5 divided by -5, that disappears on the right side of the equation. On the left, I have -20 divided by -5. I'm just going to move over here. -20 divided by -5 will be positive, and 20 divided by 5 is 4. So that is now equal to t minus 4. Bedmas backwards. We've undone the adding. We've undone the multiplying. Now what I need to undo is that exponent of 2. And the opposite operation of exponent 2 is the square root. So when I square root, there's actually two answers. There's a positive answer and a negative answer. So plus or minus the square root of 4. And the square root of 4 is just a 2. So we're going to have plus or minus 2 is equal to, and then the square and the square root undo each other and leaves us with the t minus 4. Now that's a fairly simple equation in terms of we have a minus 4 left inside the bracket, so we're going to undo it by adding 4 to both sides. And when we add 4 here, we also need to add 4 to this. So I get two answers. You'll notice the times was plural. We get two answers for this. Our time is equal to positive or negative 2 plus 4. So our two answers look like this. We've got time being equal to positive 2 plus 4, which then equals 6, or we have time being equal to negative 2 plus 4. And if we're at negative 2 and we add 4, that is actually positive 2. So what is actually happening here is that it is hitting a height of 100 meters on the way up at 2 seconds. On the way up, 2 seconds after being hit. It reaches the maximum height at the 4-second mark, and then on the way down at the 6-second mark, it's back at that height of 100. So 100 at 2 seconds, 120 meters high at 4 seconds, that was our vertex, and then back down to 100 meters high at the 6 seconds. So the times when the ball was a height of 100 meters would be at 2 seconds and at 6 seconds.